what we're doing today is 6.64. Today is the last part or last section that we're actually covering this year. And this is dealing again with solving. Now the first problem that we're looking at on this note sheet with solving is this one here. Ironically, I was going through these note sheets yesterday to make sure and kind of working them through so they all worked out. And I realized that the one on the note sheets actually doesn't work. 13 is not a real solution for it. Just with how it's set up, I set the problem up and checked it and saw, okay, that doesn't work. It doesn't give us a real solution. Ironically, I went back and checked the videos from last year just to see what happened. I started the video out and actually said exactly what I just said. I was checking the problems this morning. 13 doesn't work out, so we'll need to change it. A year later, I still didn't change that number on the note sheets, but it won't happen next year. I made sure to change it this time because it works out that 13 is not a big enough number when solving to get a real answer. It just doesn't work. So I had to make the number bigger, so 303 was a big enough number that we can actually get a real solution for this here. So again, we've done some of these here with these inequalities. So again, it's just kind of going a little more deeper and looking at them is all we're doing today. So we'll look at 2 dealing with exponentials. We'll look at 2 dealing with inequalities, or not inequalities, because this is an inequality. 2 with logarithms, and then we'll be done. And one of the biggest changes with this here is, well, we actually have an x squared. Most of the stuff in the homework and what we do don't deal with something to this degree. So we're looking at stuff that's a little bit harder than we would normally look at. Well, the first thing we can do is get e by itself. We want to get e by itself so that we can apply the natural log to it. So the first thing we can do is what? Subtract 3 from both sides, which will tell us that 5 times e to the x squared plus 4 is less than 300. What can we do next? Divide both sides by 5. Because here we're just going to be left with e to the x squared plus 4 is less than 60. Now what do we need to do to get rid of our e? We need to apply what? The natural log, because the natural log of e is 1. Natural log of e is 1. But the nice thing that we can do is move the exponent out front, and we simplify the e, which just leaves us with x squared plus 4 is less than the natural log of 60. Now on a side note, I mean, we could use our substitution, our switching property, like we did the first time we were rewriting exponentials to logarithms. Y'all remember doing that? E to the x equals 4. So the natural log of 4 equals, or e to the 4 equals x. So ln of x equals 4, switching back and forth. And we could do that, but the reason I get away from it is trying to keep track of which way the inequality sign is supposed to go. Because we're switching sides, we're changing things, and trying to keep track of that. Here, just applying ln, we don't have to worry about it. Okay, so that was more just a side note. What do we need to do next to get x by itself? We need to minus 4, which tells us that x squared is less than the natural log of 60 minus 4. Is x by itself? No. Let's use that purple. What do we need to do next? Square root both sides. Square root. Square root. Square root of x squared is x. And over here we'll have the square root of the natural log of 60 minus 4, yes? And whenever we square root both sides, we have to add the what? Plus or minus, because whatever is being squared could be positive or it could be negative, yes? So in the positive case, x would be less than the natural log, or the square root of the natural log of 60 minus 4. But the square root of the natural log of 60 minus 4 could also be negative, because it could be positive or negative. We have two cases, yes? So we also have to consider this case, and x, what's our inequality sign going to be? Less than or greater than? Greater than. Because again, whenever we multiply or divide by a negative, we've got to flip that inequality sign. So x is less than the natural log of 60 minus 4, and x is greater than the negative square root of the natural log of 60 minus 4. So if we wanted the precise answer, it'd be this right here. This would be the precise answer. If we want the approximate answer, and I'm going to go out 3 places. We get this here. Any questions on this here? Now, the reason I had to change this is because, well, ln of 60 in itself is 4.094. So if I had gotten any number less than that, would mean that ln of whatever that number minus 4 is going to be negative. So 303 is the first number that actually gives us a positive number inside the radical. That's why the other one didn't work. But that's our answer. That's all we have to do for these here. I mean, it's a little, I'd say this is a little bit more trickier than what we did the other day. Only really at this part here. The rest of it still follows the same exact stuff we were doing. We just have to remember our properties with x squared, our inequalities, and square roots. Any questions on this here? 5 plus e to the negative x is less than 14. Subtract 5, yes. Which will tell us that e to the negative x is greater than tells us that negative x is greater than what do we do next? Almost negative 1, which will give us positive x and negative natural log of 9, and our inequality sign is still greater than, because whenever we multiply or divide by a negative, we've got to flip the inequality sign. The best way I can explain this, we'll put 0. So the x value, so negative x, would technically be over here, yes? I mean on a number line. ln of 9, positive number would be over here, yes? Well, if I divide by -1, I don't have negative x anymore. I have what? So it's over here. ln of 9 is now over here. So if we said this was the inequality to begin with, it's got to flip accordingly. Does that kind of make sense? For the most part, it's a crude way to explain it, but we got to flip it. Because that is one of our answers, or if we want to approximate it, I actually have it stored away right here. Actually, look at the right one. Go on and approximate it, but I will say this. Don't give me both. Give me both. So I'll be checking this here, and then I will check this here. Because if for some reason, this one here is not too bad, because you can do negative ln 9, enter, and it's fine. Some of the other ones, like we had the other day, where you get down to x is equal to negative ln of 9 minus 4 divided by 7. I just threw numbers up there. And you type this in and forget that parentheses, or type it in a little funky, and get a number that doesn't match, isn't the right answer. That's when I'll look back to see, what did you have here? Okay, if that's right, I'll go on and take it, because it's just a calculation error at that point. Yeah. But if you just give me the number but don't give me this, I'll have to take off points for that. So it's good to put both just in case, because plugging in a lot of this stuff. This one here is not bad, but if it had been, say, negative log base 18 of 9, those are a little bit easier. The more stuff that we have in there, the easier it is to kind of fumble it up. Because all it takes is a misplace. For some reason, instead of putting -4, you put -4, so it's going to multiply them. So you'll want to put both that way that you have it. Let's look at this one here. The natural log of 2x minus 3 cubed. And that cubed is attached to the 2x minus 3, not the natural log. What can we do first? It'd be very tempting to say cubed root both sides. But we know that whenever something inside the log has an exponent, we can move it to the front. So that's telling me that I have 3 times the natural log of So what can we do now? We can divide by 3. Minus the natural log of 2x minus 3 is greater than 2. What's next? Let's put both to the base of e, because e to the ln cancels, telling me that I have 2x minus 3 is greater than e squared. What can we do next? Add 3 to both sides, because these will cancel out, telling me 2x is greater than e squared plus 3. Next we would divide by 2, telling us that x is greater than e squared plus 3 over 2. Close. We do need to make sure none of our restrictions are being violated, because the 2 that we did before were exponentials. In an exponent, we can have positive, negative, 0. We can have any real number. Here, we're dealing with a logarithm. So what's inside 2x minus 3 has to be greater than 0. Now, when we solve this here, plus 3, these, so 2x has to be greater than x has to be greater than 3 halves, yes? So that the inside of it's not less than 0. Is e squared plus 3 over 2 greater than 3 halves? Well, 3 halves, what are we doing to the top? We're adding e squared to it. So the numerator, e squared plus 3, should be greater than just 3. If we wanted to check it, we could type this into a calculator, e squared plus 3 over 2. Second, e squared plus 3 divided by 2. So as an actual approximate number, this is 5.194. 3 over 2 is 1.5. So this is already bigger than that number, yes? And it's only concluding the numbers that are bigger than 5.19. So is there any way we can get a negative inside this here? No. So that's our answer. Most of the time, and I say most, this is not always, if it's greater than, there's a good chance we don't need the restrictions. The only time that's not going to work is if what's inside has dealing with a negative x, then we'll need to just look at it and see. But most of the time, if it's negative x inside, it's going to change it from a greater than to a less than, and it'll kind of tell us that, okay, this is talking about values less than this amount, and it's looking at those there. Any questions on these here? So let's do one more, because I do have a few left. Why don't y'all go on and look through whichever ones are on there and pick which one y'all want to look at. Log of 8x to the 4th. The negative 2 times the natural log of x minus 6 to the negative 1. Because I think that's the last one. This one here does look pretty complicated, yes? Well, let's take it one step at a time, working from the outside in. So what's the first thing we can do to get the natural log by itself? Yeah, let's divide both sides by negative 2. If we divide both sides by negative 2, we get that the natural log of x minus 6 to the negative 1 is not less than or equal to, it's going to be greater than or equal to negative 3. Almost. I'd throw that negative 1 out there. Since it's applied to the x minus 6, it's not applied to the natural log, which is going to make this negative ln of x minus 6 is greater than or equal to negative 3. Now we can which shall set the natural log minus 6 is less than or equal to 3. Did one move to flip it, and then the next one to change it right back. Now we would apply e. These would cancel, telling us that x minus 6 is less than or equal to e. And then we can add 6 to both sides. Well, we have a less than, yes? And again, what's inside the log cannot be 0, less than 0. So x minus 6 here has to be greater than 0. So what do we have to do? We have to add 6 to both sides. So minus x has to be greater than 6. Well, so we have to add in that this function is between 6 and e to the third plus 6. Negative. Right past it. 7. Yeah. So we can look at the graph of this here. That's it. So the last ones are 47 through 52, which for 2 of y'all, you're about halfway done. Because I think those are also included in the wrong problems for 6.2. So if you haven't started 6.2, that's fine. Go on and look on Google Classroom for those there. I will write them up here because 6.62's assignment is still on page 341, but it should be 9, 10, 13 through 16, 25 through 27, comma 32. That's what 6.62 should be. But it is correct in Google Classroom and on the makeup assignments.